Hello everyone, welcome to Geometry. Unit 2, we're going to go over our first notes of the unit. Fun fact, I went through and recorded 3 of the first notes and my microphone wasn't on, so I'm back doing it again. So for this unit, we are going to be talking about, let me change this to yellow real quick. We're going to be talking about deductive reasoning to form a logical argument. So this is our first unit that talks about proofs. We're going to be really making geometric arguments. So just like in real life, when we have arguments, when we are trying to prove our point, we want to make sure that we're using good reasoning and good justification. So today's going to be all about reasoning. It's going to be about inductive reasoning and then also deductive reasoning. We're going to start out with an example. I know some of you guys, well, tell me about this reasoning. But the first thing I want to do is have you look at this pattern. It says example 1, what are the next two numbers in this pattern? So I take a look here and I have 5 to 13, 13 to 21, and 21 to 29. Now, I'm sure you guys were able to see, if you paused, maybe you took a chance to look at it, but each time this is going up by 8. That is the pattern. I'm going to keep emphasizing this word pattern. So if I were to add 8, the next one I would get would be 37, and then the next one I get would be 45. I'm using my observations of that each number is increasing by 8. So the next two numbers I would get 37 and 45. I'm just continuing on by adding by 8. Example 2, sketch the fourth figure. So let me put a little section over here. We'll do fourth figure. And now if I look at these figures, I'm seeing that one, I just got 2 boxes and the bottom one is shaded. Figure 2, I got 2 more boxes. It looks like an extra column is added on to the right, and the shaded one is in the bottom left. Figure 3, I'm getting the same thing where I'm adding on a column. So I'm going to use these observations and try to develop a pattern here, or continue the pattern of, it gave me this to work with. Let me show you what figure 3 looked like to me. I shaded in. And to me, it just looks like they added on another column. So I'm using my observations and what I know about this pattern to predict the next one. And that's exactly what inductive reasoning is. It's using patterns to make conjectures. Now, we're going to talk about conjectures, what it is, in just one second. But this is using an observation, a pattern, a general observation, if you will, and we're using it to make a specific guess or a specific, and there's that word conjecture, about what the next part of the pattern is going to be. So if there's 2 things I want you to know about inductive reasoning, it's based on observations. It's based about what we perceive, and a lot of the time it's based on patterns. So we're using that to come up with a conjecture. Now a conjecture, let me write it down, conjecture is an unproven statement based on observations. There's the 2 big ones. Maybe I'll highlight it. Patterns, observations. So we're using observations, we're looking at patterns, and a conjecture is an unproven statement. I'm making a statement. If I look up here at this first one, my conjecture is the next 2 numbers would be 37 and 45. So we're using that based on our general observations, and we're making a specific conjecture on what the next happening will be. So example 3, conjecture. If you are not feeling well, then you have a sore throat. So this is an unproven statement. This is just based on observations of maybe you have felt unwell and you had a sore throat and that's why. So is this statement true or false? Now, we're going to talk about this in a second, but when I'm looking at true and false, I don't want this just because I felt bad and I had a sore throat and that was the cause. Does not mean that has to be true all the time. This statement is false. It is false because, well, I'm not feeling well, and you know what? I could have a headache. So when we talk about truth values of statements, we want to make sure if we say a statement is true, it is true for every single case. If you ever say, well, it's sometimes true, that does not count. To be true, it's got to be absolutely true for every single case of the statement. If not, it is false. And when we show something is false, we will show it's false with a counter example. Now, a counter example is a specific example that proves a conjecture false. So for this first one, if you're not feeling well, then you have a sore throat. Well, I showed that that is false because I'm not feeling well and I could just have a headache. So to show something is false, we'll provide a counterexample always. If it is true, it is true for every single case. An example 4 here. The sum of two numbers is always greater than the larger number. Is this statement true or false? If false, we will always give a counterexample. So the sum of two numbers is always greater than a larger number. Here's just an example of when this statement is true. 2 plus 4 equals 6. So if I had the two numbers be 2 and 4, the sum, which is 6, that is greater than 4. So we'd say, yeah, it's true for that. But is it true for every single case? Unfortunately, this is false again. So let's take a look at which two numbers could get us a counterexample. And I'm going to say the number's 2, and instead of 4, I'm going to say -4. Because if I were to do 2 plus -4, that would be equal to -2. So my sum is -2, but it is not greater than, it's not greater than the biggest number of the two numbers, which is 2. This is not true. So a false statement here, 2 and -4, this would be our counter example. So again, if we're ever going to say that a statement is false, we will give a counter example. Our counter example, 2 and -4, if I have my sum would be -2, which -2 is not greater than 2. So this gives us a false statement. Our next type of reasoning is deductive reasoning. Now, deductive reasoning, you can probably tell that I'm going to like this one because it uses facts and definitions to make a conclusion. And you've seen me do this already. Whenever we make an equation in class in the beginning of the year, I'm always saying, what gives me this equation, or what justifies this? What definition, what facts do we know? So deductive reasoning, it's not based on observations. It's based on facts. It's based on definitions to make conclusions. Here's an example of deductive reasoning. If a measure of an angle is 90 degrees, then it is a right angle. The measure of angle A is 90 degrees, therefore A is a right angle. I'm using the fact here that if an angle is 90 degrees, it is a right angle. So when they give me A is 90 degrees, well, angle A has to be a right angle. This is a perfect example of deductive reasoning. I am using facts about what I know about right angles to conclude that another angle is indeed a right angle. And we're going to go ahead and we're going to use some examples here to kind of show you the differences between inductive and deductive reasoning. A reminder, inductive, you're looking for patterns and observations. Deductive reasoning, they're using facts and definitions. So the first one here, the rain stopped and the sun came out. Next, a rainbow will appear. So when we're looking at this part, this next, a rainbow will appear. What it seems to me is that, okay, the rain stopped, the sun came out. Based on the observation and patterns of my life and my experience, after the rain stops and sun comes out, there will be a rainbow. That's the pattern of the weather there. Rain, sun, next would be rainbow. So this is inductive reasoning because I'm using my own personal observations and my experience based on when it has stopped raining. Sometimes we get a rainbow. So that is inductive. I'm using the patterns. The next one said, Jose put $25 into his savings each week for 10 weeks. That is a fact. They're saying he did this. This happened. He put $25 into savings each week for 10 weeks. Therefore, Jose has put $250 into savings for this period. This is deductive. We are using the fact that Jose has put $25 away each week for 10 weeks. Therefore, we can use what we know about this to conclude that, okay, 10 times 25, he has 250. Deductive. We are using facts, what we know about Jose and his savings habits, good saving habits, by the way, to get deductive reasoning. Next one, it says quadrilateral RTGL is a rectangle. All rectangles are parallelograms. That is a fact. All rectangles will be parallelograms. So quadrilateral RTGL is a parallelogram. They said it's a rectangle, and because rectangles are all parallelograms, we know that the rectangle RTGL is also a parallelogram. This is also deductive. We're using what we know not only about the quadrilateral, that it's a rectangle, but we also are using our facts about rectangles are parallelograms. So deductive reasoning, again, based on facts and definitions. The first three numbers of a pattern, that should give it away right here, are 1, 2, and 4. So the next number is 7. This is inductive because that word that was shown, pattern. They are making observations. We are making observations. We got a pattern, and we're coming up with a conjecture that says the next number is 7. That is inductive because there's no facts there. We're just observing a pattern. We're making a general observation and making a specific conjecture. Okay, and then our last one here. Tell what you can conclude from the two pieces of information. So here's our first piece. It says, Mary is a veterinarian who adores all dogs. King, that's a great name for a dog, is Abby's dog. Therefore, okay, so Mary adores all dogs. So Mary, she adores all dogs. Mary adores King. Because King is a dog. And we're using the fact that she is a veterinarian who adores all dogs. And we're given a dog. So Mary adores King. Awesome. Next one. If you play clarinet. Ooh, got some like my uncle here. If you play the clarinet, then you'll play a woodwind instrument. If you play a woodwind instrument, then you are a musician. This one kind of feels like if you give a mouse a cookie, which is what deductive reasoning is all about. If you play clarinet, then you play a woodwind instrument. Well, then they go on and say, well, if you play a woodwind instrument, then you are a musician. Therefore, if you play clarinet, because that's what we started with, we can conclude, then you are a musician. All right, so I do not play clarinet, that's not me. But if I did, I would be a musician. We're using the fact about if you play a woodwind instrument, you are a musician. So we're using deductive reasoning again there. Part C, triangle ABC is an obtuse triangle. Angle A and B, or angle B and C are acute angles. Therefore, angle, and you might want to try to pause see if you can get this one, but triangle ABC is an obtuse triangle. I know that if to be an obtuse triangle, I have to have at least one obtuse angle. Well, A and C are acute, so angle A is the obtuse angle. Angle A is obtuse. Again, deductive reasoning, I'm using what I know about obtuse triangles. There has to be one obtuse angle in there. B and C are acute, so angle A has to be obtuse. And the last one, Dennis went swimming at the public pool. No one is allowed to swim unless, or without first taking a shower. That's a good rule. Therefore, oh, look at you, Dennis. Dennis, he went swimming at the pool. He was only allowed in if he took a shower. So Dennis took a shower. Yay, Dennis. Way to have good hygiene. So again, some examples there of deductive reasoning. I want to come back to this main point of inductive, patterns, observations, deductive, facts, and informations. Deductive is what we're going to more focus on as we progress through this unit. Thank you for watching. This has been our first unit, or not, excuse me, first lesson of Unit 2. I will see you guys later.